Hello learners, welcome to Education Online program. I am teacher Willa Lucia. So in our previous lesson, we talked about the equations of motion. We saw that we have like three equations of motion. So we have the first one, the second, and the third. So now this time today, we are going to look at how we shall be calculating using those equations of motion. What in particular and why do you choose a particular equation of motion to work out a number? So we are going to look at all those today in this lesson. So let's look at this. We have it as working out numbers using the equations of motion. So instead of us saying numbers, I think this sounds better when we just say questions. Let's have it as questions. So how are we going to use these equations of motion? Let's take a look at this question here. Let me write it down. We have, this will be our number one, a car. A car started from rest. It accelerates uniformly. For 5 seconds at a rate of 4 meters per square second. Calculate the final velocity. Take a look at the question. So when you read it, try to find out what has been given to you in the question and what is the question requiring you to find. So if you read that a car started from rest, what happens when a car starts from rest? Not only a car, anybody. If any object starts from rest, what velocity do you give the body? It accelerates uniformly for 5 seconds at a rate of 4 meters per second squared. Calculate the final velocity. So if you look at our question, it is also talking of uniform acceleration. What happens when a body is moving with a uniform acceleration? You'll find out that the velocities, the initial and the final velocities are usually not the same. So if we have it like that, what of the time? We said accelerates uniformly for 5 seconds. Those 5 seconds is telling you the time with which the body was accelerating. So they did not specify it like time of 5 seconds, but they're just giving you 5 seconds. That seconds there is a unit of time, which means that is time there they have given you. This, if you look at this, meters per square second, that means that this value is for acceleration, because this is the unit of acceleration. So let's look at what have they given us in the question. Let's give it as this given just stands for what is there. We are trying to summarize our question. So let's see. A car started from rest. If anybody starts from rest, that means that the initial velocity, which is u, is 0. So we shall have our u is equals to 0. It accelerates uniformly for 5 seconds. So there, the time has been given to us as 5 seconds at a rate of 4 meters per second squared. That is our acceleration. So our acceleration is equals to 4 meters per second squared. Calculate the final velocity. The question has even indicated for you exactly what they want, which is the v. So we are looking for the v. So if you want to work out this, remember we are using the equations of motion, and there are 3. You cannot use the 3 all at the same time. You need to choose one and be wise as you're choosing. Choose it wisely, because you might choose one which doesn't have an element in the question. So let's take a look at our equations of motion. Let me put them on this side. The equations. Starting from the first one, our first one is saying that our v is equals to u plus at, which we say is the first equation. Let's look at number 2. We have our s is equals to ut plus a half at squared. This is our second equation. Then we have the third equation as the v squared is equals to u squared plus 2as. So we are giving it as our third equation. Now there are 3 equations. Which equation is appropriate for our question there? So if you take a look at the first equation, in your question there, when you summarize, do you have the final velocity v? You go and check. Do you have u? You check. Do you have a? Do you have t? If you have all those things, that means you're using that equation. But if you come and see, do you have s, which is the distance covered or the displacement? If you don't have s, that means that you go ahead and look. If you have all this but you don't have s, that means that this equation is not appropriate for working out the question. If you come to the third equation also, you'll still see that there is a factor of displacement, s. So, but in our question we do not have s. So this equation, the third equation, becomes inappropriate for our question. But then if you look at the first one, all the things we want, all the things given in the question are right here in the first equation. So we are going to take that equation to work out our question. So what are we going to do? We are going to take v is equals to u plus at. So the question is telling us to find the final velocity, which is here. We have the initial velocity given to us as 0. So if you look at a, we have the acceleration, which is 4 meters per second squared. We have our t, which is the time, as 5 seconds. So we can find this final velocity from that. So let's substitute our values in this equation here. So we shall have our v is equals to, the value of u is 0 meters per second, plus the value of a is 4. So we are going to put it right here. But our acceleration is multiplied by the time. And our time here is given to us as 5 seconds. So we shall have it here as 5. So this time our v is equals to, if you get 0 plus 4 times 5, which is 20. So if you have 0 plus 20, you'll still get your 20. That means that our final velocity is equals to 20 meters per second. So that is how simple it is for you to find out, as long as you've summarized your question and then you know which equation is appropriate for your question. So that is our answer for number 1. Let's now take a look at this number 2. We have it as calculate the final velocity. Calculate the final velocity of a body traveling at 4 meters per second when it accelerates at 2 meters per squared second and covers a distance of 5 meters. So our question says calculate the final velocity of a body traveling at 4 meters per second when it accelerates at 2 meters per second squared and covers a distance of 5 meters. So if you have a question like that, the first thing you also do is try to summarize the whole question. So let's summarize and see what they have given us. They are telling us calculate the final velocity. That is what the question wants us to find. Again, is the final velocity. So our final velocity we don't have, which is the v, of a body traveling at 4 meters per calculate the final velocity of a body traveling at 4 meters per second. So the body is traveling at 4 meters per second. That means that is the initial velocity the body started moving with. So the body was already given that velocity of 4 meters per second, which is the value of u. So our u here becomes 4 meters per second. When it accelerates at 2 meters per squared second. So when you see per squared second, it is our acceleration. The question has acceleration is equals to 2 meters per second squared and covers a distance. So our s is the distance, which is 5 meters. So if you look at our question, are you seeing any t there? There is no t. That means that the journey of this body was not timed. So that's why we don't have our t here. So for you to calculate this, it means that you go to your equations of motion and find out which equation doesn't have the time in it inclusive. So the one that doesn't have time is the one we shall use, because our question, our car was, the body when it was traveling, it was not timed. So we shall see that if you look at equation 1, there is time and our question doesn't have time. We leave it out. You come to question 2, it has the s, yes, it has acceleration, it has the velocity, but then It doesn't even have the final velocity. The major thing you want to find is not in equation 2. And equation 2 has the time, which we don't need. So we throw that out. We come to equation 3. We have the velocity, the final velocity they want us to find. Or we have the initial, we have the acceleration, we have the distance. We don't have time in this, making this equation here very suitable for our question. So for us to work out that question, we shall use this equation that doesn't include time in it. Because if it includes time, if you take this, what value will you be giving? What value will you assign time? What was the time? You don't know the time. So if you use that, are you going to say 0? Because the body moved, and when it moves, that means that there is time interval. It moved with some time interval. So if it is not given to you in the question, that means the body's travel was not actually timed. So we are going to take our equation 3. So we shall have it as our v squared is equals to u squared plus 2as. So if you look at that, they want us to find v, yes, which is here. We have our u, which is 4 meters per second. So we are going to put it here as 4. But remember, our u is being squared. So instead of having it as 4 only, we shall square it. So our 4 is squared plus our 2 times, what is our acceleration? The body accelerated at a rate of 2 meters per second squared. So we shall have it times 2. What of the distance it moved? It covered a distance of 5 meters. So where there is s, we substitute it with the value 5. So we shall have our v squared is equals to 4 squared gives us what? 16. So plus, if we have 2 times 5 is 10, and then 10 times 2 will give us 20. So we shall see that here we shall have it as 20. So we shall have our v squared is equals to 20 plus 16 will give us 36. So remember, our v has a square. You need to get the square root of v. That means that you introduce the square root sign on both sides. So when you square it, you put that under the root, and then you put that under a root. These 2 here will cancel with the root. So we shall have our v is equals to root of 36 will give us 6 meters per second. So we have seen how we calculate that. So let's take a look at our last example here. So our last example says that a body accelerates uniformly at 2 meters per second squared for 3 seconds. Calculate the total distance traveled. So we have it here as, this is our question. Our example 3 there, we have it as a body starts from rest, and accelerates uniformly at 2 meters per squared second for 3 seconds. for 3 seconds. Calculate the total distance traveled. So how do we get our distance traveled? So you come back to your question and also summarize. Since they're saying that a body starts at rest and accelerates uniformly at 2 meters per second squared for 3 seconds, calculate the total distance. What have they given us in the question? We have a body starts from rest, meaning our u is equals to 0. When a body always starts from rest, the initial velocity is 0. Accelerates uniformly at that rate. Our acceleration is 2 meters per squared second for 3 seconds. Our t is equals to 3 seconds. So they want us to find the s, which is our distance. How do you find that? If you look at our question, we do not have the question is not stating the final velocity the body attained, but it's stated the velocity with which the body started moving with. It gave us the time the body traveled, the acceleration with which the body was moving. So we have all this, but we don't have the final velocity. So we are going to pick the equation that does not include final velocity in it, which is the second equation of motion. We shall have it as our s is equals to ut plus a half at squared. Because if you look at this, there is no a final velocity in this equation. So we shall have, since we are finding our s, what is u? We have our u as 0. So we are substituting where there is u, we substitute our 0 times our t. What is the value of t? What is the time interval for the travel? So our body traveled at 3 seconds plus a half. The body was accelerating at a rate of 2 meters per squared second. So we are multiplying it by our acceleration, which is 2, times our time, which is 3. But then remember, our 3 here is not only that, but it is squared. So we are introducing this square sign also. Write that, because our t was already squared. So when you multiply a number by 0, it is 0. So we shall have our s is equals to a half times 2 times 3. When you square 3, what do you get? So it is more like 3 times 3. So when you have 3 times 3, what happens? How many is that? So we shall have it as 9. So we're going to have this as 9 here. So now we have that. This 2 here, we can reduce our number by reducing, by cancelling out the 2 there. We shall have this 2 will cancel with this 2 here. So that means that our distance covered was 9, because here we are only left with 9. So we shall have our 9 meters. So that means that the body traveled a total distance of 9 meters. So now this is how we use our equations of motion to find out, to work out numbers. The major thing you need to know is that what is it that is not in your question. When you know what is not in the question, you can pick appropriate equation for working out the question. So you try to summarize also. You try to know if a body starts from rest, what kind of velocity will, or what is the value of the initial velocity. You get to know that. But then if you summarize your question on like that, you find it is much more easier when you're going to substitute it in your equation. So whenever you're calculating, try to pick appropriate equations for your question, Because if you pick the wrong one, it will become very hard when you're calculating it, because you'll find there is a number, there is a figure, but it doesn't have a value. Why? Because it is not the right equation for that question. So since we now know how we're going to use our equations, you're going to find more in your in the PDF. You try to download and find more questions. You also try to work it out. So with this, we're coming to the end of our lesson for today. We shall meet again in our next lesson with more on linear motion.